All right, good morning, everyone. Today is Tuesday, September the 7th. Just got over the Labor Day weekend. So hopefully everyone had a fun, safe, and restful break. 3 days. All right. So as of today, all of you should have 3 quizzes complete: 1.02, 1.03, and 1.05. So this is day 2, lesson of 1.06. We got day 2 is today, day 3 is tomorrow. All right, we got 2 bellwether problems. So let me go ahead and just poll the class and see what everyone got for the first one. All right, the first one, A, B, C, or D. Let's see if we can start off this Tuesday, 100%. Some people just logged in and fell back asleep. Maybe they're still working on the problem there. That's okay. All right, so everyone that was able to do, it looks like, okay, some guesses here. So the answer is D, as in dog. It's definitely not A. C would have been a better guess than A for sure, right? Because this is an odd polynomial, right? Power of 3. So the only choices that should have been like just like a good random guess would be C or D, right? Yeah, only these two would apply to an odd power, right? Nobody should have chosen A or B if they looked at this and say, all right, it's not even, so they can't have the same end behavior, right? Odd have different end behavior. So C or D would have been the better. Close your eyes and pick one, right? All right. The second one. What did everyone get? The second one. All right. Looks like everyone who's responded got it right. The answer is A. So yeah, the 10 of you who responded, nice job. Yeah, D and A. Nice job, everyone. That's from last week. All right, today we're doing multiplicity. So we're going to graph a function at roots with different multiplicities. So I think somebody mentioned multiplicity last week. I forgot who it was, but we're going to talk about it today. All right, so you have your paper, pencil, pen, and even graph paper if you have it. All right. Right. This is just review on this page talking about the fundamental theorem of algebra here. So with the fundamental theorem of algebra, that's the one where we look at like zeros, right? Or a function, and you have to factor it, and you can see the different factors, and you count them up to see what the degree polynomial is. That's just the short answer of it. But doing that doesn't say what the multiplicity is or how many zeros or how many roots that we'll have, and that's what the multiplicity is. So the multiplicity is the amount. So it's the amount of that root that we have. All right, so this page is pretty important. So when looking at a graph or even looking at a polynomial, you're gonna, I'm going to ask you questions. You're going to have to be able to look at a graph or polynomial and say, all right, is this going to be odd or even multiplicity? Because when you graph it, whether it's odd or even will affect on how it looks. So the easy one, well, like I guess they're both kind of easy in their own respect. Odd multiplicity, these are the ones that pass through. So it could be one, it could be three, it could be five, it could be seven. But all odd multiplicities will pass through your x-axis. So right here, this is passes through the x-axis. So this would be an odd multiplicity, whether it's a 1, a 3, a 5, a 7, and so forth. So again, odd multiplicities will pass through the x-axis. Super important that you know that. I would definitely write that down. Odd multiplicities pass through the x-axis. You should know that after today. All right, now the second one also is very important is even multiplicity. So these bounce. So you can see right here, it doesn't pass, it touches, but it doesn't pass through the x-axis. So this is even. It could be a 2, it could be a 4, it could be a 6, and so forth. So again, odd pass through x-axis, even bounce. Okay, let's look at these three examples. All right, now feel free to write these three down. I have these on different pages, their own individual page. All right, so looking at this polynomial, before we dive into this question and determining all the multiplicities and stuff and graphing it, looking at this, can someone tell me in chat or on mic what degree polynomial is this? So like some people are saying 6, and I would agree with you. Yeah. So to determine that, you just, this is multiplication, right? And we don't have to multiply it all out to determine this. You can just count up the exponents. We have, this is x plus 3 to the first power. This is x plus 2 to the second power. And this is x minus 3 to the third power. So that's 1 plus 2 plus 3 is 6. So this is a 6th degree polynomial. Now, also looking at this, can someone determine the end behavior of this without graphing it and without multiplying out? Can someone determine what that is? What is the end behavior of that polynomial? It's from last week. Very good. They both go to infinity. Absolutely. Yeah, so they both go to infinity. So I'm just going to, do that just to show that they both go to infinity. All right. Now look, okay, now let's go through this. What are the zeros? So what are the zero? You know what? I asked the question, what degree polynomial is? It says it right here. This is a 6th degree polynomial, as stated on the page. Hopefully, you answered that without actually reading it. All right. So what are the zeros? So go ahead and chat. Write down all of the zeros of this polynomial. Yeah. So what Enzo wrote is correct. Yeah, you would say, well, they're negative. It's -3, -2, and 2, right? Oh, I'm sorry. Sorry, -3, -2, and 3. Those are the 3 zeros. And then you would expand on that by saying, well, that's just -3. This is -2 with a multiplicity of 2. And this one would be 3 with a multiplicity of 3. So all the ones that have multiplicity of 1, you don't state it, it's implied. So nobody should write -3 multiplicity 1. You don't do that. Oh, I didn't know you guys did an algebra too. Well, that's good to know. All right. So what we're gonna do is on your graph and on your paper, go ahead and just do like a rough sketch of a graph. We're gonna plot these 3 zeros. So we have one at -3. We have one at -2. And then we have one at +3. Okay. All right. Next, now looking at this one on the graph, what happens at this when we graph it? So my question is, does it pass through it or does it bounce? It passes through. I agree. All right. For the one at -2, does that pass through or does it bounce? It bounces. Yep. And then at 3, does it pass through or does it bounce? It passes through. Correct. Now, what I did was I went ahead and this right here at the very beginning, I just did the end behavior. So that's how I'm going to start it. So we know that the far left, the -3, that one passes through, right? So we'll just do that, okay? And then we'll do arrows or whatever. At -2, we said it bounces, right? So I'm just going to continue. So I don't know how far it goes down; doesn't really matter. But we know it goes up, but then it bounces, right? And then it goes down, and then this last one, um, it passes through, but because it's a multiplicity of 3, it has this like, this wave to it. So remember with multiplicities of 3s, that's a cubic. So we should expect some type of like S curve, right? So I did a little one just to kind of represent that this is a cubic. So again, cubic is right here. The power of 2, it bounces. And then the first one we said it passes through. So you got to make sure your graph, the end behaviors match of what we said it was going to be, which it does, right? The ends both go to infinity, and that's what we expected. So I like to kind of do this at the very beginning just to see, what we know it's supposed to do. And then when we actually graph it with multiplicities and what's going on, it should also match, right? And then, of course, we can always just go to Desmos and confirm, right? Definitely confirm. All right, how are we feeling about what's going on this page? Looks like pretty good. So let me just recap it. Given a function, we want to, well, I like to do the end behaviors at the very beginning just to know what it's going to look like. You don't have to. We need to write all of the zeros out. So all the zeros in this case would be -3, -2, and 3. The -2 has a multiplicity of 2. 3 has multiplicity of 3. And then we know that it passes through at -3. We know it bounces at -2. And we know that it passes through, but in an S-like formation, right? So, and that's it. That's using the multiplicities to graph our function. Now, this graph is 100%, it is definitely wrong. Like none of these points are going to be right. I could always go to the graph and grab some just to confirm. One point that we're going to talk about is the y-intercept here. I should have done that at the beginning. We'll do that coming up here pretty soon. Maybe on this one, we'll do the y-intercept real quick. So everyone try this one. Go ahead and write down the zeros and graph it real quick. Let me give you all like, I think 2 minutes should be enough. All right. All right, before we graph this and write down the zeros, can someone tell us how can we find the y-intercept? Noah says set x equal to 0. Yeah, so we plug 0 in for x. So let's quickly do that. Yeah, we're going to plug 0 in for all of the x's, right? So 0 here, 0 here, 0 here. So when we do that, we're going to get, we'll get 1 squared times -1 squared times 2, right? So that's going to be 1 times 1 times 2, which equals 2, right? So the y-intercept, is equal to 0, comma 2. Would all of you agree with that? 0, comma 2? Okay, and this is stuff we've done since your freshman year, Algebra 1, right? So let's go ahead and just plot that points on our graph. 0, comma 2. So when you do these, I would say the y-intercept is one of the points we should also graph, and I probably should have done it on this problem. I just didn't think of it. But real quick, the y-intercept of this one is going to be 0. I'm just going to really do it real quick in my head. So that's going to be 3 times 4 is 12, and then 12. Oh man, what's 12 times 27? Yeah, 324, right? Does that even does it even work out properly? Feel like 0, 0, and 0. So we get 3 times 2 so 2 squared is 4. So 3 times 4 is 12, and then negative 3 cubed is negative 27. Negative 27 times, no, that's right. Yeah. So negative 324, right? Yeah. Okay. Just thought it was a little too big or too small, right? So so we can see that my y-intercept that I have on this is definitely not even close to what it's supposed to be. Um, but yeah, so in this case, it's obviously not to scale and not correct. But on this page, we definitely can plot our y-intercept. All right, class. What are the zeros of this polynomial, of this fifth degree polynomial? What are the zeros? So we got negative 1, multiplicity 2, 1, multiplicity 2, and negative 2. Okay. All right. So, volunteer who would like to graph this for us. Volunteer like to graph this? Noah, go ahead, please. To make it easy, make sure you up on the tools you can select the thickness of your pen. I would choose the largest thickness of the pen, and if you can use something other than black, but it's fine. Actually, you're drawing it pretty big. It's easy to see. All right, blue's good. So he did the negative 2, the negative 1, and the positive 1. Nice. And then you might want to switch to a different color again just for the line. But that works too, you know. I'm just being picky, right? Oh, I like it. I like it. So it passes. So negative 1, multiplicity 2. That's this one. So that bounces, which he showed, right? 1, multiplicity 2. It bounces also, right? So there's the bounce again at 1. And then, oh, did I not type this right? Yeah, this is. Uh, hmm. So no, that's right. Yeah, no. And then negative 2, multiplicity 1, right? And then the end behaviors look pretty good. All right. So one benefit of doing your y-intercept, if you get your bounces correct, you should be on the same side as your y-intercept, which it's here, right? If we were on the other side, we would have bounced off here, and then we wouldn't be able to pass through your y-intercept. So it adds another layer of, I guess, correctness, a way to ensure that we're getting it right. I don't know if I'm using the right words here. Another layer of protection. There we go. Yeah. So by having this here and doing the bounces and stuff, we pass through the y-intercept properly. So yeah, without even checking the end behavior of this, we're probably correct because we actually pass through the y-intercept. This is a fifth degree, so one goes up, one goes down. Because you're leading, your coefficient is positive. It's the standard It's just the standard end behavior here looking like this, right? As x approaches negative infinity, y approaches negative infinity. As x approaches positive infinity, y approaches positive infinity. So nothing tricky about that one. All right, how did everyone do on this one when you did it on your own? Perfect, perfect, perfect. Looking good. All right. Again, just to say what I've been saying here, remember, even powers bounce, odd powers pass through. Again, even powers bounce, odd powers or odd multiplicities pass through. All right, let's try this one. Let's do 2 minutes. Also, calculate the y-intercept when you do it on your own. So when you do this y-intercept, it's not going to fit on the graph, but at least you have it. All right. All right. Class, what is the y-intercept for this one? Zero comma 864. So I see some of you are putting zero. Remember, so y-intercept is a coordinate. So like what Noah put, 0 comma something. Noah, don't, just because only you put that answer doesn't make you wrong. Okay. So one thing I like what really happens, it's rare, is that a majority of the class gets the problem wrong. And there's always one person that gets it right, but they doubt themselves. Not saying this is the scenario where the entire class is wrong except one person, but one thing I want to point out that is a very simple mistake. When looking at this, what is 0 squared? What is 0? Yeah, 0 squared is 0. So that one, that term, or not term, that factor in the very front, it's easy to skip over and to do the math with everything else. You also might be in the habit of thinking anything to the 0 power is 1, but yeah, in 0 to the second power or third power or even the first power is still 0. So yeah, and 0 times anything is what? Zero, yeah. Zero times anything is zero. So yeah. So it looks like no, it looks like you just overlooked this first factor, and maybe you thought zero squared is positive one. Um, that is a common mistake. I don't blame you for make it, but I would mark it wrong. I don't blame you, but I mark it wrong. I don't know if that makes any sense. I understand your mistake. How about that? I understand where you're coming from. uh, no, it happens to the best of us. Happens to the best of us. All right. So now that we got that taken care of, I'm gonna go ahead and just plot that coordinate. So, oh, that was definitely the wrong pen tool. Let me try that again. All right, 0, comma 0. All right, class. What are the zeros and their multiplicities of this 8th degree polynomial? All right, so looks like we got a lot of agreement here. 0 multiplicity 2, 2, 3 multiplicity 3, and -4 multiplicity 2. I think those look pretty good. All right, all right, all right. Volunteer want to graph these for us? Volunteer. All right, Enzo, give it a shot. Please use blue for the points and use yellow or green or whatever color that is for the line. All right, so we got the points plotted. All right, how's everyone feel about Enzo's sketch of our graph here? End behaviors look good, points look good, bounces look good. Yeah, I think that's pretty good. So one thing that I would change is probably, yeah, the only thing that I would like to see a little different would be this right here. And I know it's hard to draw on the board here, but let me show you what I might have done, which may not be much different than Enzo. But yeah, if you did it on a TG, I would give you credit for it. There's nothing wrong with that. All right, so it bounces at 0. So I'm gonna go left or right here. So it bounces at -4. It bounces at 0. It it passes through at 2. And then it does pass through at 3, but in a kind of a curvy fashion, I guess. So, all right. So it's going to look like, I don't know. Let's see. Bounces, bounces. And then we said at 2, it passes through. Yeah, I missed. Let me back up a little bit. Try it again. And then at 3, it does a it's a cubic, so it should make like almost like an S. Yeah, I wouldn't say that's any better than what Enzo did. And it's kind of cramped. So yeah, I didn't do a better job. But maybe on your paper, like on a TGA, it would look a lot better when you're actually using a pen or a pencil instead of your mouse, right? And so I think you did just fine. Just fine. Yeah, so it bounces at -4, it bounces at 0, it passes through it in a line at 2, and then this is a cubic. So I tried to make it look like a little S curve to show that it's a cubic, right? Um, didn't do a very good job, but it's good enough, right? And look at this. So one of our zeros is, well, 0, right? 0 multiplicity 2. Look at this. 0 multiplicity 2 is right there. So it crosses the x-axis. So if one of your zeros is 0, which it is, we really don't even have to think about the y-intercept because it's part of the 0. Does that make sense? Yeah. I think I have one more for all of you. Oh, okay. This was a little different. All right. So this one, you're given the graph, and now we have to write our function. Now, when you write your function, it says, what is the polynomial function equation of least degree for the graph shown? Now, I think you don't have to multiply it out. So I would just like you to write your answer in factored form. Like, for example, on this previous page, right? This answer is in factored form, right? So I don't expect any of you to multiply these out. So for this page here, I want your final answer of this graph to also be in that factored form. So to kind of get you started on this, looking at this graph, we should be able to look at this and pull out all of the zeros, right? Pull out all the zeros. We could also be able to look at, whether it bounces or passes through at like an S formation. So all of, these characteristics, you should be able to pull out the multiplicity along with those zeros. So let's start there. I want everyone to use this graph and write down all of the zeros that you see and their multiplicity. And let me give you, I think 1 minute from this point should be enough to do that. Ready, go. All right, class, go ahead and chat. Go ahead and write down what you got for the zeros. I see someone went right for the answer, and that's fine. So we have -1 multiplicity 3, 1, 2 multiplicity 2. I think those look pretty good, right? Yeah, I think those look pretty good. Yeah, we can see right here, this is -1 multiplicity 3. Now, how do we know it's multiplicity 3? Right here. Yeah, it's the S curve, right? Yeah, it's the cubic. Yeah, so this is -1 multiplicity 3. That's just +1, it passes through. And this is 2 multiplicity 2. We know that because it bounces. So I would agree with you, right? All right, next. Um, what we're going to have to do now, this is going to be something new. We're going to write this out like this. Now we have this a in front because this a is our coefficient, and this a could be positive, it could be negative, it could be a number other than one. So looks like some of you already kind of jumped to the final answer I saw in chat, and that's fine, but it may not be correct. So one thing we need to do, just like in past problems today, we talked about the y-intercept. So looking at this graph, what is the y-intercept of this graph? Remember, intercepts are coordinate form. So make sure you give me the coordinate, not just like the y value. So 0, -4. And again, guys, on your TGA, you're going to have to give me whether it's, this unit or the next unit or one of them. When you guys give me like intercepts, x or y intercepts, it's a coordinate. Don't just give me the number. Like some of you put -4. Remember, it's a coordinate 0, -4. All right. So 0, -4. So anybody have an idea of how we can use the y-intercept to, I guess, find what a is? Yeah, we just plug it in, right? We just plug in 0 for x, so 0 for all the x values, and then 4 for the y value. Remember, f of x and y mean the same thing, so f of x would equal 4. So we're going to set that up. And then, this is easy math, right? We're just going to easily solve this. So I'm going to give you all, I think 1 minute should be enough to solve for a. Ready, go. All right, what did a equal? Yeah, a equals +1. Nice job. We'll just show that quick math here. And we divided by -4 both sides, and that's how we get a to be -1. So if a equals if a equals +1, did it change anything from what we thought it was maybe going to be? Yeah, it didn't, right? Because anything times 1 is itself. So that's why the answer is that and not something else. Now, if I plan better, for next year I'll change this problem, but maybe I should have made a been like a 1/2 or something. If a was maybe a half, maybe that would have been a better example to trick some of you, right? But we always have to do this step. We always have to use the y-intercept to plug it in to solve for the a value, because a value may not be 1. Hint hint, your quiz, your test, your a value may not be 1. Now, instead of actually doing all of this math and plugging and chugging, is there another way we may be able to approach this problem? Graph it. Yeah. So if you graph it, what would we have to do? Yeah, just yeah, we have to basically compare it to the original. And then what if the original didn't match the picture on the screen? What would we have to do? We find A. Yeah, either you solve for A or you guess and check, right? We can just, and quickly in Desmos, keep changing that A value. We could have graph or put this in Desmos and then just kept changing the number out in front to like, I don't know, like 1 or 2 or 3 or 4 and so forth until it matched this. So we could have guessed and check. So that's always an option. Maybe not the best option, but it's still an option, right? Especially on a quiz or a test, if it's multiple choice, we could easily guess and check, right? We got 4 choices. Just plug them all into Desmos and see which one actually works. That's a great way to do it, right? Yeah. And so it says we would check the difference in Y. Um, Maybe. And so that may, the difference really may not tell us other than like, if this number was maybe smaller, like -5 or -6, then that to me would probably tell me that the A value is greater than 1. And if it's less than -4, or sorry, not less than, greater than, so like -3, -2, -1, that would probably tell me the A value is a fraction, so less than 1. But then now we're just overthinking the problem. So yeah, I don't really know if it would even help us other than, you know, pointing out obvious facts, right? All right. So everyone feeling about given a graph and having to create the function. Pretty good. Pretty good. I love it. All right. Everyone's looking pretty solid. I love it. All right. One thing I want to point out. So sometimes the modules are wrong. Um, if someone would be great and verify, because this was last year and I didn't verify if they fixed it this year. I'm assuming they didn't fix it because I feel like they never do. Even when I report it, they don't fix anything. So in the module, this says, let's see, there's a infinite. Okay, correct. So yeah, somewhere in the module when they talk about this example, they forgot the little 2. So like yeah, in their little example, there should be a 2 right here, and their flow of work. So after this first step, they do fix it, and they do stick it back there, but there should be a 2 right here. So yeah, so check that, and hopefully it doesn't confuse you. But yeah, it should be a 2 right there, and that's on page 3 of 5. Yeah, bottom of yep. It's so Enzo. Did they fix it or is it still missing? It's not fixed. Okay, so this correction page still applies. There should be a 2 right here, and there is not. So, all right, everyone. Well, any other questions before we stop for the day? Looking like everyone is feeling good about this, which is good, right? All right, everyone. Well, thanks for coming, and as always, I hope you learned something, and I will see you all tomorrow. Have a good rest of the day.